Good day, students. So in this group, we're going to be going over some examples and evaluating and solving logarithmic expressions and equations. But before we start, we're going to review some of the properties that we considered in the previous clip. So write it down. Review on properties. Properties of logarithms. Properties of logs. Okay. You can write log as the short form of logarithms. Okay. Review on properties of logs. Okay. So let's take a look at them one by one, and I'll state the role that each plays in what we want to accomplish today. So the first one is the product property. Product. I'm going to write it in this form. Log base b of x plus log base b of y is equal to log xy base b. Okay? This is the log property written in reverse order. If you watch the last clip, you notice that I wrote this first and then this second. But this it can be written in any direction. It doesn't really matter. It just basically means when you multiply two numbers, you have the sum of the logs. Okay, and then you also have the quotient property. Quotient property. If you have the difference of two logs is what? Of the numbers. The difference of two logs is simply the quotient of the numbers. Log base b of x over y. Okay? Alright, so these are the quotient and product properties written in reverse order. What I want to help you to see here is I wrote it in reverse order because I want you to see that these two properties are used to condense logarithmic expressions. So you use to condense logarithmic expressions, okay? So you notice you have two logs here, so using the reverse of the product property, they've been condensed into one. And then you have two logs here, they've been condensed into one. So this is the product and quotient properties written in reverse. All right, now let's take a look at the power property. The power property basically is log base b of x to the n equals n log base b of x. So basically this power gets dropped down. You have a power coming down, so power down. Okay, so you have n log base b of x to the n. This property is used to create uniformity. Okay, if you want to make your logs identical and your coefficients are different, this coefficient right here is different, you just basically move the power to the front, you move the coefficient as a power, you can move this up over here to this form to create uniformity. Okay? Alright, and the last two are the inverse properties. So for we have inverse. Inverse, if you have log base b of b to the y, these two are opposites, so they cancel each other out. So you have y as your answer. And then another inverse property that I like you to know is that b to the log base b of y is equal to y. Okay? These just illustrate the inverse relationship between exponents and logarithms. They're inverse relationships, okay? So these two properties are used for elimination, okay? They're used to eliminate the log. So these two are for elimination. Maybe write that. They're used for elimination. Okay, so when you're solving logarithmic equations, sometimes you might have to condense, make the expressions uniform, and then finally you have to eliminate the log. Okay, and if you want to eliminate, you can use one of these two properties. Okay, so we're going to apply these to some examples. Let's take a look at some evaluation examples. So first one, we're going to evaluate. Number one, log base 3 of 1 over 27. Okay. Now, I want to use the inverse property to eliminate this log, but I can never change the base. The base is always constant. I can change this to whatever I want. So if I can write this as a power of 3, then I can eliminate, I can use the inverse property to cancel the base of my exponent, and then the power of my exponent will be the final result. Okay? So how can I express 1 over 27 as a power of 3? Well, we know that if we break 27 down, 3, 9, 3, 3, 27 is 3 to the third power, right? So I can rewrite this expression as log base 3 of 1 over 3 to the third. Okay? Now, I can now use the reciprocal property to move this to the numerator. So this now becomes log base 3 of 3 to the what? Negative 3. This is using the reverse of the reciprocal property, or the inverse of the reciprocal property. Now you see, this is my goal. I need the base and the argument of my log to be identical so that I can use the inverse property of logarithms to cancel out. So that's the case. The base and the logarithmic argument are identical, so these two cancel out, but they cancel out and you just left for the power. So this and this cancel each other out, and your final answer is negative 3. Okay? Alright, let's try another example. Example 2. What if we have log base 1/3 of 1 over 243. Okay? Now, my goal is to make the base and the argument of my logarithm identical. I can never change the base, but I can change the argument into anything I want. So I want to write this as 1/3 to a certain power. So how can I write 1 over 243 as 1/3 to a certain power? So 1, we can just leave 1 alone. Let's focus our attention on 243. Okay, let's break that down. 243, I can extract 3 out of it because if I add the 3 digits, I get 2 plus 4, 6 plus 3, 9. Since 3 goes in and 9, 3 goes into 243. So take out 3, you have 81. Take out another 3, you have 27. Take out 3, you have 9. Take out 3, you're left with 3. So 243 is basically 3 to the 5th power. Okay? So this becomes, I can now write this as log base 1/3 of 1 over 3 to the 5th. Okay? Now, can I express 1 as a power? Yes, 1 can be written as any power, okay, because you always get 1. So I can write this as log base 1/3 of 1 to the 5th over 3 to the 5th. Okay? 1 to the 5th is exactly the same as 1. Okay? Now what I'm going to use the reverse of the inverse of the quotient of powers property to extract this 5 from 1 and 3. So it's going to become log base 1/3 of 1/3 raised to the 5th power. Remember, the power of quotients property allows you to distribute the 5 in. Now the reverse of that just allows you to factor out the 5 from the powers to the outside. Okay? Is this what I wanted? This is exactly what I wanted. I needed the base and the argument of my logarithm to be identical so I can use the inverse property to cancel them out. So are they identical? Absolutely. So these two cancel each other out since they're inverses. This and this cancel out, and you're left with 5, and there goes your final answer. Alright, now let's take a look at another example on evaluating logarithmic expressions. On this one, number 3, we have what is log base 1/5 of 1. Okay, so now the goal again is to make the base and the argument of my logarithm identical. So I have to express this argument as a power of 1/5 because I cannot change the base. Okay, so 1/5 to the what power gives you 1? That is a question. 1/5 to the what power gives me 1. So we're going to use something called, we went over this before, the zero property. It tells you that any number other than 0 raised to the zero property of exponents, any number other than 0 raised to the 0th power equals 1. Okay, so guess what I'm going to do here? I'm going to replace 1 with 1/5 to the 0th power. So we have log base 1/5 of 1/5 to the 0th power. Okay, is this what I want? That's exactly what I desire because I want the base and the argument of my logarithm to be identical. So we can use the inverse property to cancel them out in their inverses. And our final answer is simply 0. So there you have it. Okay? Alright. Alright. Now, in the next set of problems, we're going to be solving exponential and logarithmic equations using the properties that we just looked at. So, for this set of problems, the instruction is to solve. Okay? To solve. Alright, question number 4. For if we have the equation 3 to the 5x equals 27. Okay? Now, we want to get rid of this exponent. So to get rid of the exponent, we're going to use the opposite, the inverse of the exponent, which is log. So we're going to use the inverse property to get rid of this. So you notice that the exponential base here is 3. So we're going to use the log of the same base to eliminate this exponent. Okay, so what I'm going to do on the left side, I'm going to write just give me a minute. I'm going to write log base 3 on the left side and log base 3 on the right side. Now, why did I write log base 3? Well, it's because the base of my exponent is 3. So on the left side, I'm going to just bring this down, 3 to the 5x, and on the right side, just bring down 27. Alright? So whenever you have an exponent of a certain base, you take the log of the same base, you take that of both sides, and that will help you eliminate the exponent on the left. So if you look on the left side, using the inverse property of logarithms, you notice that this and this, the base and the arguments are identical. So these two are inverses, they cancel each other out. So you're going to be left with 5x on the right equals log base 3 of 27. Okay? Now, in order to eliminate this log, I need to make this argument an exponent with the base of 3. I need to express this as a power of 3. We know that 27 is 3 to the third power, right? So I'm going to write 5x equals log base 3. Instead of 27, I'm going to write it as 3 to the third power. Okay? Is this sufficient to eliminate the log? Absolutely. Because if you notice, the base and the argument of my log are identical. So that gives me a right to cancel both of them out. And you're going to be left with 3 on the right side. So we're going to have 5x equals 3. And then using the properties of algebra, you just divide both sides by 5. And then our final answer, x, equals 3 over 5. Okay? And there you have it. Okay, now, moving along to question number 5. For question 5, we're going to do the problem log base 3 of x plus log base 3 of 4 equals log base 3 of 2. Now we're going to solve that. Okay, this is 3 right here, and that's 3 also. Alright, so before we can eliminate the logarithm from either side, they have to be condensed first. Okay, so condense and then eliminate. So how do we condense? We want to condense first. So to condense, we're going to use, since we have a plus, we're going to use the product property of logarithm. Remember, the product of two numbers is the same thing as the sum of their logarithms, base b. So since we have the sum of logarithms, using the reverse of the product property of logarithms, this can be written as log base 3 of 4 times x. You can write x times 4, but multiplication is reflexive, is commutative. Multiplication commutes, so you can write this as 4x or x times 4 is the same thing. So 4 times x, because addition of logarithms is the product of the numbers. So multiply the arguments, equals log base 3 of 2. So we have accomplished our condensation. Okay? Now after condensing, now we have to eliminate. Okay? We have to eliminate the logs. To eliminate the logs, we're going to use the inverse property. Okay, the inverse property. So we notice that the bases of the logs are 3. So I'm going to exponentiate these logarithms using using 3 as a basis of exponentiation. So on the left side, I'll put a big 3 here. On the right side, I'll put a big 3. And then what I'm going to do is I'm going to exponentiate both sides using 3 as a base. So I'm going to have a little log base 3 of 4x. And on the right side, I'm going to have a little log base 3 of 2. Okay? So I use 3 as my basis of exponentiation because that's the base. And now I'm going to eliminate the log. So right now, on the right side, on the left side, using the inverse property of logarithms, these two are inverses, so they cancel each other out. So you'll be left with 4x. And then on the right side, these two are inverses also, so they cancel each other out. And then you have equals 2. And then to finish it up using the properties of algebra, just divide both sides by 4. Properties of equality, and then you're going to have x equals 1 over 2. It's not 2, okay? You got to be careful because you divide the top by 2 and divide the bottom by 2, so you end up with 1 over 2. Okay? So there goes your final result. All right, let's try out one more example. Actually, 2 more examples. Let's do number 6. It's pretty straightforward. Number 6, we have we want to solve the equation log base x of 16 equals 2 over 3. Okay. All right. We do not need to condense anything here because we have one logarithm on one side. That's good enough. If we have more than one log on any side, then we condense. We don't need to condense. We just need to eliminate. All right. So how do we eliminate the log? To eliminate the log, we just need to use the inverse property, okay? So the base is x, so the basis for exponentiation is going to be x. So I'm going to exponentiate both sides using x as the base. So I'm going to put a big X on the left and a big X on the right. And then on the left, I'm going to write a little log base x of 16 equals, on the right, I'm going to write a little 2/3. So basically, the left side of this equation got exponentiated, and the right side also got exponentiated. The basis was x, because the base of my original logarithm was x. Okay? Alright, now I'm going to use the inverse property to eliminate the log on the left side. Notice what happens here. These two are inverses, so this and this cancel out. So you're left with 16 equals x to the 2/3. Okay? Now I need this power gone, so I'm going to use the power property to eliminate this power from the right side, but it's obviously going to affect the left side too. So what power can I raise this right side to get rid of 2/3? Or to make it unity, or 1? I multiply it by the reciprocal, right? So if I reciprocate this, it's going to be 3 over 2. And since I'm raising the right side to 3 over 2, I have to raise the left side also to 3 over 2. So we're going to have 16 to the 3 over 2 equals, now if we multiply this, it becomes 1. This equals x, because 3 goes here once, 3 goes here once, 2 goes here once, 2 goes here once, so you just have 1. So you're going to have x equals 16 to the 3 over 2, using the reflexive property of equality. And then I can use the fractional exponents rule to do this. Or power, let's use fractional exponent rule. The different ways of doing it. So I can write this as the square root of 16 raised to the 3rd power. Okay? Let me write my 2 smaller so you don't think it's times 2. So it's the square root. Actually, for square root, you don't have to put a 2 there, right? So you can put a little 2, but you don't have to put anything there. So what's the square root of 16? The square root of 16 is 2. 2 raised to the 3rd power. What is 2 raised to the 3rd power? 8. And there goes your final result. Alright? Okay, now let's take a look at the last example, number 4. Actually, that's not number 4. Question number 7. So for question 7, we're going to solve a logarithmic equation of the form 7 of the form log base 2 of 5x minus log base 2 of 2x plus 1 equals 3. Okay? We can see obviously on the left side that we have more than one log. So what must we do here? We have to condense. Okay? How do we condense? Well, we have a difference of logarithms. We know using the quotient rule that the quotient of two numbers the log of the quotient of two numbers is the same thing as the difference of the log of the two numbers of the independent numbers base b. Okay, so we have a difference here. So using the reverse of the quotient property, this can be written as log base 2 of 5x divided by 2x plus 1 equals 3. So we have just condensed our logarithm into 1. Now that we've condensed it, it's now easy to eliminate using the inverse property, so eliminate. Alright, so how do we eliminate? Well, all we just do is look at the base of our logarithm and use that as our basis for exponentiation. So the base is 2. So what you do is you put a big 2 on the left side and a big 2 on the right. Okay? And then what do you do next? You're going to replace it with, you're going to write a little log base 2 of 5x over 2x plus 1 on the right equals a little 3. So I exponentiated both sides using 2 as a base. Alright? So on the left side, you notice that this, any inverses, they cancel out. So you're left with 5x over 2x plus 1. And on the right side, 2 to the third is 2 times 2 times 2, which is just simply 8. Alright? Now to finish this off, this is a fraction on the right, so we can express the number on the left as a fraction. We can cross multiply. So we cross multiply, bottom goes to top, bottom left goes to top right, and bottom right goes to top left. You multiply them, and when you cross multiply, you end up with 5x times 1, which is 5x, equals 8 times 2x plus 1. On the right side, we distribute the 8 to the 2x and to the 1. So that gives us 5x equals 16x plus 8. Okay? Next thing we can do is we can subtract 16x from both sides. And then that leaves us with negative 11x equals 8. Finally, divide both sides by negative 11. And your final answer, x equals negative 8 over 11. So there goes your final result. Okay? Alright. So thanks so much for taking the time to watch this video. Please feel free to subscribe to my channel just by clicking up here. You can also share this video with your friend via Facebook or Twitter. More videos can be found on mydoorserve.com. Thanks again and have a wonderful day.